Next topic, assignment with restrictions. The problem of not assigning ith job to jth machine can be solved by taking a very large cost infinity of this assignment. So if you have an assignment problem in which there is a restriction that you cannot assign ith job to jth machine, then such problem can be solved by taking a very large cost infinity of this assignment. Further, if one man can do two jobs, one man or one machine can perform two jobs, that is, two jobs are to be assigned to one man or one machine, then this problem can also be solved. How to solve? By repeating the man's column or by repeating the machine's column and introducing a dummy row to maintain the square matrix. So in this way, two jobs can be assigned to one man or one machine. Similarly, if two similar jobs are to be assigned, two similar jobs are there and we have to allocate two similar jobs to different machines or to different person, then what we will do? Then write two identical rows of the two jobs separately. So we have to write two separate rows in which costs are identical. That is, two jobs are identical. Then write down two identical separate rows for these two jobs. So in this way, different situations can be handled. Then solve these problems with usual method. So let us see one example how to solve problems with restrictions, assignment problems with restrictions. So let us see this example. The following is the cost matrix of assigning 4 clerks to 4 jobs, 4 key punching jobs. Find the optimal assignment if the restriction is clerk 1 cannot be assigned to job 1. What is the total minimum cost? So look at the cell C11. The cell C11 does not contain any cost, and it is given that we cannot assign this clerk 1 to job number 1. So how to solve this assignment problem? There is a restriction that we cannot assign clerk 1 to the job 1. So the problem of not assigning clerk 1 to job 1 can be solved by taking a very high assignment cost for this assignment. So we take C11, this cost, as infinity, and other costs we write as it is. And when we take a very high cost of assignment, that is when we take infinity in this cell, what happens when we perform any addition, any subtraction? It will remain infinity, it will not change to 0, and therefore we cannot assign this clerk 1 to job 1 because this will never become 0. Now let us solve this problem with restriction that clerk 1 cannot be assigned to job 1 by usual method. Now what is the first step? Subtract minimum element of each row from all other elements in that row. Now what is the smallest entry minimum element in the first row? Is 0. So when we subtract 0 from all the elements in the first row, it will not change. The elements in the first row will not change. So first row entries are infinity, 5, 2, 0. What is the smallest number in the second row? 4. So subtracting 4 from all the entries in second row, we get 4 minus 4, 7 minus 4, 5 minus 4, 6 minus 4. Now smallest element in the third row is 3. Subtracting 3 from all the numbers in the third row, we get 5 minus 3, 8 minus 3, 4 minus 3, and 3 minus 3 is 0. Then smallest number, minimum element of the fourth row is 2. Subtracting 2 from the fourth row, we get 3 minus 2, 6 minus 2, 6 minus 2, and 2 minus 2. Now apply step number 2. What is step number 2? Repeat step 1 for columns. What is the smallest number in the first column? It is 0. So subtracting 0 from the first column will not change element of first column. So elements of the first columns are infinity, 0, 2, 1. Now subtract smallest element of the second column, which is 3, from all the numbers in second column. So 5 minus 3, we get 2, 3 minus 3, 5 minus 3, 4 minus 3. What is the element, smallest element of the third column? subtracting 1 from all the elements of third column, we get 2 minus 1, 1 minus 1, 1 minus 1, 4 minus 1. And for the fourth column, smallest element is 0. So numbers in the fourth column will not change. Now apply step 3. Cover all zeros with minimum number of horizontal and vertical rows. Look at the rows containing single zero and make an assignment. So in the first row, there is a single zero. So we make an assignment in this cell in the first row, and when we make assignment in a row, we have to draw a vertical line. Then in the second row, there are 3 zeros. In the third row, there is a single zero. So we use this zero now. Because this zero is already crossed, from the remaining, in the remaining 3 numbers, there is a single zero. So we use this zero for an assignment, and since it is an assignment in a row, we draw a vertical line. Now look at the rows containing single zero. Now in the fourth row, there is no single zero left. So now consider first column, and there is a single zero in the first column. So we make an assignment here, and we are making an assignment in a column. So we draw a horizontal line. Now column number 2 does not contain single zero. So in this way, all zeros are covered with 3 lines, 2 vertical lines and 1 horizontal line. Now we want 4 assignments, and there are only 3 assignments, or there are only 3 lines, and 3 is not equal to order of the matrix. So this is not an optimum solution. So number of lines are 3, 2 vertical, 1 horizontal, and it is not equal to order of the matrix. So this is not an optimum solution. So apply next step, step number 4. What is step 4? We require smallest uncovered number. So what are the uncovered number here in this cost matrix? Infinity, 2, 2, 2, 1, 1. So smallest uncovered number is 1. Here, the smallest uncovered number is 1. Subtract this smallest uncovered number from all the uncovered numbers, add the same number to the numbers which are on the intersection of horizontal and vertical lines, and do not change other numbers. This is a step number 4. So this is step number 4. Subtract the lowest uncovered number in the matrix from all the uncovered numbers. Add it at the same number to the numbers which are on the intersections of horizontal and vertical line, and do not change other numbers. So let us perform this step number 4. What are the elements in the first column? First number is infinity. Infinity minus 1. It is an uncovered number. So infinity minus 1 is infinity. 0 is on the line. Do not change it. So infinity 0. Then subtract 1 from 2 because 2 is uncovered number. So 2 minus 1 is 1 and 1 minus 1 is 0. So infinity 0, 1, 0. Then elements of the second column. 2 is uncovered number. 2 minus 1 is 1. 0 is on the line, so as it is 1, 0. Again 2 minus 1 is 1 and 1 minus 1 is 0. So 1, 0, 1, 0 are the elements of second column. Then third column. 1, 0 is on the intersection. We have to add 1 here. Do not change this 1. Add 1 here. So 1, 0 plus 1 is 1. So 1, 1, 0, 3 as it is. 1, 1, 0, 3. And elements of the last column. 0 as it is. On the intersection we add 1. We get 3, 0, 3, 0, 0. So this is a step number 4. Then repeat step 3 again. After step number 4, again perform step number 3. Look at the row containing single 0. So first row contains single 0. Make an assignment here and we draw a vertical line for this assignment in the first row. Look at the second row, it contains 2 0. Look at the third row, it contains single 0. Use it for an assignment. Draw a vertical line. Then look at the fourth row, there are 2 zeros. Now after fourth row, we look at the columns. First column contain 2 0, second column also contain 2 0. We have to make assignments in 2 rows. Row number 2 there is no assignment, and row number 4 there is no assignment, but second row contain 2 0, fourth row also contain 2 0. And First column contains no assignment, second column contains no assignment. But both of the column contains more than one zero. This is a situation where we get an alternate solution. Since remaining rows and columns where assignments are not made, contains more than one zero. So here we get alternate solution. Use any one zero out of the two. We use any one zero for an assignment. But remember that we want a single assignment in a row and in a column. There should be a single assignment. We get alternate solution. So let us make an assignment for the second row in the first column, and for the fourth row there is a choice in the second row, either in the first column or in the second column. So in the first solution, we make an assignment for this clerk number 2. We assign a job 1, and for clerk number 4 we cannot assign job number 1 now because it is assigned to clerk number 2. So let us assign job number 2 to clerk 4. So this is the one solution. So first solution is first clerk is assigned to job number 4, second clerk is assigned to job number 1, third clerk is assigned to job number 3, fourth clerk is assigned to job number 2. Now here we can interchange these two jobs because there is a choice. So second solution is first clerk is assigned to job number 4. Now second job, we now interchange these two. Second clerk we will assign to second job, and fourth clerk, third clerk, there is no change. We will assign third job to third clerk. Now for the fourth clerk, we will use job number 1. So we have interchanged these two. So in this way we can have two solutions with the same assignment cost. We will find the assignment cost. The minimum assignment cost is in the first case, what are the cells in which assignment is made? This is a cell C14. What is the cost in C14? In the original matrix, C14 is this cost, 0. Then what is the cost in the second row? Second clerk is assigned to job number 1. So when clerk second is assigned to job number 1, the cost is 4. So 0 and 4. Clerk number 3 is assigned to job number 3. And the assignment cost is again 4. And finally, clerk number 4 is assigned to job number 2. Four is assigned to job number 2 and the cost of assignment is 6. So total assignment cost is 14. Let us calculate the minimum assignment cost for second solution. You will get same cost. Clerk number 1 is assigned to job number 4. So first assignment is same. Third assignment is also same. So let us write down this cost now. First clerk is assigned to job number 4. So in the second assignment, we use same cost 0. Then second clerk is assigned to job number 2. Second clerk is assigned to job number 2 in the second solution. Then job number 3, there is no change. Third clerk is assigned to job number 3. So the assignment cost is 4 again. And clerk number 4 is assigned to job number 1. And assignment cost in this case is 3. So we will add this cost 0, 7, 4, 3. 0, 7, 4 and 3. Seven plus 3 is 10 plus 4 14. So we get same assignment cost. So this problem has the alternate solution. So this is a problem how we solved the assignment problem with the restriction. Assignment problem with the restrictions can be solved by usual method. And what is a procedure? Here in this problem, we cannot assign clerk 1 to job 1. So for that, what is a procedure? We have to take a very large cost for this assignment. That is, we use infinity cost for this assignment and apply usual method. That is Hungarian technique.